Hello everyone. This video is on section 8.6 part 2 titled Solving Radical Equations with Two Radicals. In this video I'm going to be going over a version of the Knewton Alta assignment for section 8.6 part 2. Please understand that the version I'm seeing in this video may or may not be the same questions that you'll see when you work on it on your own. But the objectives will be the same, the types of questions you see will be similar, and the way you go about doing them would be the same. All right, so I'm hoping watching me do these here will help you in some way when you work on it on your own. Alright, so here's the assignment page. You won't see the words preview of, but you will see the title of the assignment, the mastery bar, the objectives, right? Looks like there's only the one objective here. Solve a radical equation with two radicals, two radical terms. And I believe they'll all be square roots, because yeah, I think doing it with cube roots or higher roots would be too difficult for the scope of this course. And then you have your questions, right? And below each question should be a feedback button to send feedback to Knewton if you want. You will not see this instructor cheat button, right? It won't be there, but you will see a more instruction button. Right? If you click on this, it'll provide you with reading material or videos that might be able to help you out when you're struggling on an objective or a question. Alright, so as I said, one objective here says solve a radical equation with two radicals. And I'll just write these out and start going through them. Alright, so you're seeing here two radicals. Right, on the left side of the equal sign there's a radical, there's a square root symbol. You have the square root of a minus 4. Then you have this term outside the radical, right, plus 1 equals, and then on the other side there is a totally separate radical, right, a second square root, the square root of 2a minus 7. Alright, so I'm going to write out the steps here that I'm going to perform to solve these equations that have two radicals, two square roots. The first step is to isolate one of the square roots, one of the radicals, which is already done here. All right, you see how this right side, this radical, this square root is already alone. It's already isolated on the right side. Alright, so isolate one of the radicals. Totally done. And since these will be square roots, I want to undo that radical. We're going to square both sides. Alright, now here's the tricky part. Alright, the right side's easy. Okay, the right side is just going to be, the square root of 2a minus 7, raised to the second power. That'll undo the radical, and I'll be left with just 2a minus 7. No problem, right? The right side is the easy one. It's the other side that has two terms. There's a radical term plus a non-radical. Remember, we're taking that entire side, right, the square root of a minus 4, and then plus 1, and we are squaring this. And don't forget what that means. That means you're taking that entire side, right, the square root of a minus 4 plus 1, and multiplying it by itself. So multiplying again by the square root of a plus 4, minus 4, square root of a minus 4, plus 1, right? You're taking that whole side, both terms, and multiplying it by itself. So please don't just square both terms, right? You're not just squaring this and squaring that and calling it a day. You're doing FOILing, you're doing distributing. So I take the square root of a minus 4 and distribute it to the other factor. And then I take 1 and distribute that, and we'll combine like radicals. Alright, so again, the right side, the side with the isolated radical, the side with that radical that's alone, that's easy. You square both sides, you square that side, you just get rid of the radical. So the other side, you multiply out. Now, if you take the square root of a minus 4 and multiply it by the square root of a minus 4 again, you're going to get a minus 4. Alright, square root times square root, the square root's gone, you got just a minus 4. Then, the square root of a minus 4 times 1, we have plus, the square root of a minus 4. And then again, we have plus 1 times the square root of a minus 4. Now I'm distributing the 1, which is another square root of a minus 4. And then 1 times 1 is 1. So yeah, here are the 4 terms I get after FOILing. The 2 terms times 2 terms on the left side equals 2a minus 7. And now I'm going to simplify. We'll combine some like stuff over here. We've got a, then the negative 4 and the positive 1 go together. That's minus 3. And then these terms are like radicals, right? The square root of a minus 4, and then I have another square root of a minus 4 being added to that. So that's plus 2 times the square root of a minus 4. So there's the left side. This is what I get when I square the left side and combine like terms and like radicals. I get a minus 3 plus 2 times the square root of a minus 4. And this is equal to, again, the right side was easy, 2a minus 7. Alright, so that's step 1 and 2. I get one radical alone, one square root alone. Undo that by squaring both sides, but the other side with the multiple terms I'm going to have to FOIL. And then combine like terms, combine like radicals. Now the third step is just repeat steps 1 and 2. Alright, because notice I've got a radical term. I've got a radical term here. Right, a term where one of the factors is a radical, one of the factors is a square root. So, just like I said earlier, let's isolate this. Let's get this term alone. So that'll involve subtracting a and adding 3. Right? I would subtract a from both sides, and then I would add 3 to both sides, and that'll get all the terms that aren't a radical, that don't have a radical attached to the other side. Right, so next page here. So the left side, now I have this positive 2 times the square root of a minus 4 equals, and then over here 2a minus a is a, negative 7 plus 3 is negative 4. Right. And then once I've isolated the radical term, then I square both sides. Right. Now once again, you got to be a little careful with the radical, with one of these sides here. I square this side, I square this side. Now before with the radical I didn't have this factor of 2. Remember, this is multiply this by itself. You square the 2, that'll be 4 times, and then squaring this square root of a minus 4 is is the quantity a minus 4. Right? Not just 4a then minus 4. It's 4 times the quantity in parentheses a minus 4. Right? This 4 is 2 squared, and this quantity a minus 4 is the square root of a minus 4 squared. Right? Equals, and then over here, just like earlier, a minus 4 squared, that's a minus 4 times a minus 4. Right? Not just a squared minus 16. Please don't do that. You can't distribute powers over sums and differences. You have to multiply it out like this. This would be a squared minus 8a plus 16. Right? When you multiply those two together, FOIL and combine like terms. Alright, then solve the resulting equation. Because after doing those first two steps twice, you should have a polynomial equation. You should have gotten rid of all the both radicals. You solve the resulting equation. And then, of course, as always with equations, you check your solutions. Let's say, and then check your solutions. Now, always check solutions in the original equation. All right, so over here I'm distributing the 4. We have 4a minus 16 equals a squared minus 8a plus 16. Then I would take everything to one side, 0 on the other. I'll just take everything to the right here. So we have a squared minus 12a. And then if I add 16, that'd be plus 32. And this factors to a minus 8 times a minus 4. All right. So the possible solutions are a equals 8 or a equals 4. But again, please check these in the original equation. So here was the original equation. All right. In fact, I'll write it out again. All right, I'll write it out again. We'll check these solutions. So the original equation was the square root of a minus 4 plus 1. When was this equal to the square root of 2a minus 7? And don't forget, and I've said this several times in many videos, when you see this square root symbol, or the 4th root, or 6th root, or 8th root, any even root, it's a symbol asking you for the positive root. All right, so don't forget that. All right, so let's check this one. A equals 8. A equals 8. Well, left side, we'd have the square root of 8 minus 4 is 4, then plus 1 equals, and then the right side, 2 times 8 is 16, minus 7 is 9, and this is 2 plus 1 equals 3. Yes, 3 equals 3. Yes. So a equals 8 is a good solution. A equals 8 works. Now let's try 4. All right, let's try 4. A equals 4. Well, put in 4 for a here, you get the square root of 0. All right, 4 minus 4, then plus 1 equals the square root of, now 2 times 4 is 8, minus 7 is 1, and this is 0 plus 1 equals 1. 1 equals 1, yeah. Both of these work. Both 4 and 8 work. Now sometimes they don't, right? Sometimes they don't, and you've seen that in other videos. In section 8.6 part 1, you saw some radical equations that had extraneous solutions. So just be careful. Please be sure to check your solutions back in the original equation. All right, so there are multiple solutions, and they asked us to separate those by commas. So 4 comma 8, right? 4 and 8 both work here. Great. And after each question, right, there should be an answer explanation, which please read, right, whether you get it right or wrong. If you get it right, read through it and make sure that you got it right for the right reasons, that you didn't just get lucky. Or they might also go over some alternate method that you might like better and try in future questions. But then if you're, if you got it wrong, definitely read the answer explanations, right? You want to figure out why you got it wrong, where you went wrong, so hopefully you can learn from your mistakes and, do better in the future. All right, so what I did for this question is what I'm going to do for all the questions in this video. That's the only objective. All right. Solve a radical equation with 2 radicals. So yeah, so this is very similar. All right, so I'm going to write this out and do it on some paper for you. All right, so once again, there are 2 radicals, one on both sides. The one on the right side is already isolated. So once again, I'm going to undo that by squaring both sides. All right, so remember the whole entire left side. All right, the square root of z plus 4, the radical term, and then plus 1, or the non-radical term, that whole thing is getting squared. And the same thing with this other side. Now the other side's the easy one, because it's the one with the radical alone. Right. Now again, remember, you're not just squaring the square root of z plus 4, and you're not just squaring 1. You're taking this and multiplying it by itself and foiling. Now if you were to do this, you'd have z plus 4, which is the square root of z plus 4 times the square root of z plus 4, remember it is z plus 4, plus, 1 times the square root of z plus 4, but you'd have that twice, so you have 2 of those, right? Plus 2 times the square root of z plus 4, and then plus 1 times 1. Right? So again, it's not just z plus 4 plus 1. Please don't do that, right? Don't distribute powers over sums or differences. And the other side's simple. Right, the square root of something and then to the second power, that undoes the square root. Just left with 3z plus 1 over here. Alright, and then combining some like terms, the 4 and the 1 go together, but you know what, I'm just going to do this. Say, hey, here's the radical term that I need to isolate. Alright, get this 2 times the square root of z plus 4 alone. So in order to do that, I'd subtract z from both sides and subtract 5 from both sides, because 4 plus 1 is 5, right? So minus 5. Alright, so then I'd have 2 times the square root of z plus 4 on the left, and 2z minus 4 on the right. Now something I'm noticing that didn't happen in the first example is that both sides, have a factor of 2 in common. So I'm going to divide both sides by 2. All right, you don't notice you don't have to do this, but I'm going to do that for this one because I'm noticing every single thing has a coefficient that's a multiple of 2, every single term. 2's cancel over here, leaving me with the radical alone. All right, the square root of z plus 4. And then if I divide each of these terms by 2, I'll have z minus 2. All right. And then starting over, right? You isolate the radical like I've done just now. I'm going to undo the radical, square both sides. So that gives me z plus 4 on the left. And then again, don't forget, you're not just squaring z and 2 here, right? You're taking z minus 2 times z minus 2 again and foiling and combining like terms. You'd end up with z squared minus 4z plus 4 if you were to do that. Alright, then I'm going to do this. I don't want to bring in a new piece of paper. I'm just going to say, let's bring this over here. I'm going to take everything to the right side, everything to one side, 0 on the other. We'd have 0 equals z squared, and then subtracting z would give me minus 5z here, and then subtracting 4 would give me nothing else, right? No constant term. And this is very easy to factor. We just pull a z out. This is z times z minus 5. So the only possible solutions are z equals 0 or z equals positive 5. But please don't forget to check back in the original equation. So I'm pulling this down here. Now there's the original equation right up top. Right up top there. Now I'll do this out loud. Right, if z were 0, you'd have the square root of 4, which is 2, plus 1. You'd have 3 on the left, 3 on the left, and 3 times 0 plus 1 is 1. The square root of 1 is 1. You'd have 3 on the left, 1 on the right. 3 equals 1 is false. So z equals 0, I'm crossing out, putting a big X through. This is an extraneous solution, doesn't work. How about 5, right? Z equals 5. Well, if I put in z equals 5, you'd have the square root of 9, which is 3, plus 1 is 4. You'd have 4 on the left, and 3 times 5 is 15, plus 1 is 16. Square root of 16 is 4. You'd have 4 equals 4. So z equals 5 works. Right, so that's the only one, and that's the one I'm going to enter back in the assignment. right, just z equals 5. Wonderful. And once again, please read through the answer explanations. Okay. All right, another question just like that. And all these are pretty similar, with 2 square roots in the equation, one on each side. I'll write it out. Okay. So, and 2 radicals, 2 square roots. One of them is already isolated, right? This square root of u plus 21 is already alone on the right side. So now I square both sides to undo that radical. All right, now the left side has 2 terms, so I'm going to be foiling here. It's the square root of u plus 1 times the square root of u plus 1 again, and then you would FOIL. On the right side, when I square the right side, that square root would go away, the radical would go away, and I just have u plus 21. All right, but the left side, I'd have u, right, the square root of u times the square root of u, and then you'd have 1 times the square root of u, but twice, right, when you do the outer and inner in foiling. So I'd have plus 2 times the square root of u, and then 1 times 1 is plus 1. Right. And then I would like to get this alone. Right, this 2 times the square root of u term, that radical term, I'd like to get that by itself. So I'm going to subtract u, subtract 1. We get 2 times the square root of u equals, now when I subtract u, u's are gone, and subtracting 1 gives me 20. And again, I have a nice thing where I can just divide both sides by 2 if I don't like the 2 here. So I divide both sides by 2, giving me the square root of u equals 10. And if the square root of u is 10, once again I square, now I've isolated the radical, right? Square both sides. Gets rid of the radical. U equals 10 squared is 100. And don't forget to check it. Don't forget to check it back in the original equation. The square root of 100 is 10, plus 1 is 11. I'd have 11 on the left, and then 100 plus 21 is 121. The square root of 121 is 11. I'd have 11 equals 11. So this works. This is a valid solution to this equation. Alright, pretty simple one there. Only one number to check. Alright, so 100. Great. Again, please read through the answer explanations. Alright, and this last question should be the final one if I do everything correctly. And you see it's again very similar to the previous questions. So let's write this one out and I'll work on it. Okay. So once again, one of the radicals is already alone, one of the square roots. So then I square both sides. So I have the square root of x and then plus 1, the 2 terms over here, right, squared. So remember, this means take the square root of x plus 1 times the square root of x plus 1 again and FOIL. Multiply it like you would any polynomials, and then here the square root of x minus 3, square, that'll just undo the square root. So I have x minus 3 on the right side, and x plus 2 times the square root of x, right, when I do 1 times square root of x twice, 2 times square root of x would be total, and then plus 1. And then I want to isolate this, right? Now I want to isolate this radical term with the 2 times the square root of x. Well, subtract x, subtract 1, we have 2 times the square root of x equals, the x's would go away, and then negative 3 minus 1 would be negative 4, and then I can see again, oh, these are nice and even. dividing both sides by 2, get the square root of x equals -2, but I can tell you right now this isn't going to have any solutions. Because remember this symbol, and I've said it a bunch in other videos as well. When you see the radical symbol, and it's an even root, square root, fourth root, sixth root, and so on, it's representing the positive, the non-negative even root. So on the other side, how can something that's not negative on the left be something that's negative on the right? So this will never happen, but say you didn't recognize that. Like, oh, I've isolated this radical, now I'm going to square both sides again, and I get x on the left, and -2 squared is +4 on the right. Now once again, don't forget to check. Now if I plug in 4 for x, square root of 4 is 2, 2 plus 1 is 3. I'd have 3 on the left. Plug in 4 for x over here, 4 minus 3 is 1. I get the square root of 1, I get 1 on the right. 3 on the left equals 1 on the right. That's no good. So I'm going to big x through this. That is an extraneous solution that doesn't work back in the original equation. So all the solutions I found, didn't work, meaning that this equation, this equation here has no solution. And in your assignments, for these equations, they tell you in the instructions, if there is no solution, you enter this symbol, this empty set symbol, the circle with the slash through it, as your answer. And that's not showing up here. I have to go to the keyboard thing, go to sets, and there's the empty set symbol. Wonderful. Alright, and again, please read through your answer explanations. And that should be it for this version of this assignment. And as I said at the top of the video, please know that the questions I'm seeing here may not be the same questions you see, when you work on the assignment yourself. But the questions are similar, the objectives are the same, and how you would work on the questions should be similar as well. So I'm hoping that watching me go through these 4 questions here helps you out in some way when you're working on it on your own. And thanks for watching.